Everybody, and I mean everybody, is in a mad dash to build artificial general intelligence, AGI, an AI that's as smart as a human. But there's this massive kind of hidden roadblock that's slowing the whole thing down. So today, we're going to break down exactly what that roadblock is and talk about the surprising key that might just unlock the future of AI.
All right, here's the plan. First, we're going to pinpoint the core bottleneck holding AGI back. Then, we'll dive into the solution, something called user simulation. From there, we'll explore this really cool partnership between AI and these simulators, look at some brand new challenges that large language models are throwing into the mix, and finally, we'll talk about what the future of all this research really looks like.
So let's just get right into it. With all the mind-blowing advances we're seeing in AI, you'd think we're on the fast track to AGI, right? But the truth is, progress is hitting a pretty serious wall. So, what's really going on here?
Okay, let's unpack this. The problem isn't a lack of brain power or a shortage of computing power. Nope. The real bottleneck, the thing slowing us down, is how we train and test our most advanced AIs. And it all boils down to one thing: data.
You see, for an AI to get smarter, it needs to interact with us, with people. But relying on real, live humans for this is, frankly, a massive headache. It's unbelievably slow to collect all that data, it is wildly expensive to pay people for their time, and it's almost impossible to scale up to the millions of interactions you actually need. On top of all that, every person is different, so the tests aren't even easily reproducible. This is the wall.
So how in the world do we get around this human data problem? Well, the solution proposed in the research we're looking at is both elegant and incredibly powerful: user simulation. The idea is, instead of waiting around for real people, why don't we just build digital ones?
To put it simply, user simulation is all about creating these little computational agents that act just like real humans when they talk to an AI. You can think of them like AI-powered crash test dummies, but instead of testing cars, they're testing AI on really complex stuff, like writing code or doing research.
And these simulators really come in two main flavors. On one hand, you've got your model-based kind. These use clear, explicit rules that we humans write. They're great because we can look inside and see exactly why they're doing what they're doing. On the other hand, you have data-driven models. These just learn patterns from giant piles of real user data. They can be amazingly accurate, but they often work like a black box. We don't always know why they behave the way they do.
Now, these simulators play two absolutely critical roles. First off, they give us scalable evaluation. You can test your AI literally millions of times, automatically, on the cheap, and get the same conditions every time. And second, they can generate enormous amounts of synthetic data to train the AI in the first place, which is a lifesaver when real data is hard to come by. This completely smashes through that human data bottleneck we were just talking about.
But the idea here is actually even deeper than just testing. It's not just about building simulators for AIs. The research makes a really compelling case that building better AIs and building better user simulators are actually two sides of the very same coin. They have to grow and evolve together.
And check this out, because it illustrates the point perfectly. A recent study on chess players found something totally fascinating. It turns out, human players who were teamed up with an AI partner that was specifically tailored to their skill level actually did better than players who were given a way more powerful superhuman AI. Just think about that for a second. The raw power of the AI wasn't the winning factor, it was compatibility.
And that brings us to the crucial takeaway. For an AI to be a really good partner, it can't just be a super genius. It has to actually understand us, our limits, how we think, our little quirks. And to do that, it needs to have a pretty sophisticated model of human behavior running inside its own head. It basically needs its own internal user simulator.
Okay, this all sounds pretty good, right? But the arrival of large language models, the technology behind things like ChatGPT, has introduced a brand new, kind of tricky problem. They call it the superuser problem. So here's the dilemma. The very thing that makes an LLM a great AI assistant, having practically infinite knowledge and giving perfect answers, is the exact opposite of what you want in a realistic human simulator. Real people, well, we have gaps in our knowledge, we make typos, we get confused. An LLM trying to act like a human can be too perfect. It becomes a super user that doesn't act like a real person at all.
And this really points to a deeper issue, something called the cognitive gap. Psychologists talk about how we have two ways of thinking. There's System 1, which is our fast, intuitive, gut reaction thinking, and LLMs are actually getting pretty good at faking this. But then there's System 2. That's our slow,
deliberate, step-by-step logical reasoning. And that is where current LLMs really struggle. And it's a huge part of being human. To build better simulators, we have to figure out how to bridge this gap.
So, where does that leave us? What does all this mean for the future? How do we actually build these better, more human-like simulators? And by doing that, clear the path to AGI?
While the central argument of the research is crystal clear, we can't just keep focusing on making our AI agents more and more powerful in a vacuum. The development of these highly capable agents and the creation of truly realistic user simulations have to move forward hand in hand. They have to be seen as equally important goals that actually push each other forward.
And this isn't a job that's just for computer scientists and engineers. Not even close. To really model human behavior, to capture all our weirdness and complexity, we need a massive interdisciplinary effort. We need to pull in experts from psychology, cognitive science, human-computer interaction, the list goes on. It's really about blending all that technical know-how with a much deeper understanding of what it actually means to be human.
Which leaves us with one final, really fascinating question to chew on. To build a truly smarter AI, one that can work alongside us and genuinely understand us, do we first have to solve the incredible challenge of building a more perfect digital reflection of ourselves? That, right there, might be the core question that drives the entire next wave of AGI research.